Good afternoon, everyone, and welcome to this lecture. We are dealing with electric potential. In the previous class, I think we had dealt with electrostatic potential energy of a system of charges, and we had done some really good questions, particularly this one. This was from a NEET exam way back when NEET was slightly tougher, more tough than present day exam. So probably this is the toughest question that you can get. Remember this. The more likely question that I think that you will get would be of the circular wala nature, and I not the circular or the rectangle, the square wala nature. We have covered this in the previous class. Everyone understands the question that we had done? Or any doubts? Anyone? Okay, then we will move ahead. In the previous class, we had seen the potential created by a point charge. It is kq by r. Is it positive charge, kq by r? If it is a negative charge, it is minus kq by r. In today's class, to begin with, we'll start with potential due to certain more type of charge distribution. So what I'll do is, just to give you a quick recap, we will start with each and every type of distribution once again, and we will write the electric field as well as the electric potential together, so that everything is at one place for each of you. Now, some of these may not be for you when they make a JEE, sorry, not JEE, when they make the NEET tougher, then probably you can have discussion. So let us write all these options together. You can make, what you can do is you can make a table. And how are you going to make the table? I will show you how you make a table. You can make this table, or you can write them in this form. The first type of charge distribution is the point charge. As I was talking about the table, how you can make the table is, if I have a table, I will show you how you can make that table. Let me see if I have a table somewhere so that I can give you a description. Else I will have to make it. And if I make it, I will just take more time. Okay. If you have to make a table, this is how you will make a table. In one column, you will write the type of charge. What type of charge is there? Point charge, line charge, this charge. Then you can draw a diagram. The diagram is already there. So you can put it in this column. Diagram column should be slightly bigger. Then you can write the electric field ka formula in one column, and then you can write the electric potential ka formula in the next column. So what you will make essentially would become your table in which you have everything written together. For example, if I have to break this this description in that form, what will I do? I will write here number one. I will write here point charge. I hope you understand what I'm saying. I will write here point charge in column number 2. What will I do? I will draw this diagram in this column. I hope you are understanding what I'm doing here, bacha.
Yes, sir.
In the third column, what will I do? I will write the value of this electric field in the third column, and in the fourth column, I will write the value of electric potential like this. Do we understand this? So this is how you can make this table. It's easier for me to just take it from here. Otherwise, I have to paste everything, and that might not look good. So, do we understand this, everyone? How to make this table?
Yes, sir.
So you can make it, put it column wise, so that just reading that column, in fact, whatever we have done up till now, that will come in that one table only. Once you know the electric field, you multiply it by the charge, you will get the electric force. So electric field, say you can find out the electric force. If you know the electric potential, you multiply it by the charge, you will find out the potential energy of that charge. So in one table, bacha, you will have everything that you need. Okay, you understand this?
Yes, sir.
Okay, have you noted down for this point charge
Yes, sir.
table wise? Okay, now I hope you can write them point wise for this. And here also I have the graph for both them, so you can make a column as well for drawing the graph, and I will show you the graph as well. What do I mean by graph? The graph of electric field or graph of electric potential may be here. Here, this is a graph of electric field of a circular ring, and I told you where it is maximum. Do you see this, where it is maximum? It is maximum at a distance of r by 2. Do we remember this?
Yes, sir.
The value of electric field for this charge, line charge, is kqx by r square plus x square raised to the power 3 by 2. Did I give you this formula? Yes or no? Did I give you this formula? No? You can note it down now. Electric field at any point is kqx upon r square plus x square raised to the power 3 by 2, where x is the distance of the point from the center of the ring, and r is the radius of the ring. And you can see the direction of electric field. If it is a positive charge, it will be like this on this side. On this side, it would be like this. Do we understand this?
Yes, sir.
Electric field at the center. How do you find the electric field at the center? I'm giving you all this together in one place, so that electric field at the center of the ring will be 0. You can see the value of x is 0. So the electric field at the center of the ring would be 0. If you talk about electric potential, now this formula will only be used when they make a very tough question on electric potential of a circular ring. But if that is the case, then the formula is 1 by 4 pi epsilon naught, or k times q divided by r square plus x square ka under root. So these are the formulas for electric field and electric potential due to a ring. What are the points that you have to remember about this? So you can also write them in one column, special points or whatever. Have you noted this down, bacha, everyone? Have you noted it down? Is everyone noting it down? Yes or no?
Yes, sir.
Let me know once you are done.
Done, sir.
Boys, are we done? Then these are some points that you can note down. At center, x is 0. So you can see at center x is 0. So your electric field at the center is going to come as 0. And your electric potential, and remember this is a very important term. What is the electric potential at the center of the ring? KQ by R. KQ by R. Point number 2, you may not it's not so important for you. Point number 3 is again not important, but you must remember that the value of maximum field occurs at R by root 2. R by root 2. Do we understand this?
Yes, sir.
I hope you are making that table. Everyone is putting things in the table, yes or no?
Yes, sir.
Okay, once you have noted it down, please let me know.
Done, sir.
Boys, done? Good. Shall we move ahead? Then you come to this infinite sheet. It has a surface charge density sigma. What do I mean by surface charge density? This sigma is equal to charge per unit area. Do we know this? Yes or no?
Yes, sir.
So sigma by 2 epsilon naught is the field due to this. If I have to find out the potential, so this is the formula for potential here. Because it is an infinite sheet, you do not write this formula. Because it is an infinite sheet, you cannot find out a point whose potential is 0. So what you can do is you can find out the potential difference between 2 points. If I have 2 points, you can find out the potential difference between the 2 points. If this is R1 point P and this is point Q, the distance of this point is R2. You can find out the potential difference between the 2 points. You can write Vp minus Vq as sigma by 2 epsilon naught into R1 minus R2. Do we understand this? Have we written this? Let me know once you are done, bacha.
Done, sir.
Guys, let me know. Waiting. Don't worry. I will not move unless you say, sir, we are done. Done, sir?
Yes, sir.
Okay. This was surface charge, infinite surface charge. We move on to this one, and the next one is charge conducting sphere or conducting shell or non-conducting shell. When I say all these things, what it means that the charge is on the outer surface of the sphere. Do we remember this? So if it is a solid, it has to be a solid conducting sphere. If it is a hollow, it could be conducting as well as non-conducting. Do we remember this? Yes or no? No or yes?
Yes, sir.
Everyone remembers it? Now you must remember what is the electric field outside, and I told you that electric field outside is same as the electric field due to a point charge, and therefore the electric potential is also same as the electric potential due to a point charge. Do we understand this?
Yes, sir.
So this is the formula for electric potential and electric field. It is written in different forms. You can just remember this form for electric field and this form for electric potential. The other formula is written in the form of sigma. If you want, you can remember it. If you don't want, you may not remember it. That is not required. That is not required. Let me know once you are done. Then we'll come on to the most interesting aspect of this, which I wanted to highlight. Let me know once you are done, bacha. I hope everyone is understanding what we are writing, bacha. Any doubt, anything that you don't understand, please ask. This is also a revision of what we have already done.
Done, sir.
Boys, sir.
Done, sir.
Okay, sir. Then, most important aspect, on the surface of the sphere, what you do, you put the value of small r as capital R. Capital R is the radius of the sphere, bacha. So you will find out electric field on the surface. We have already done this. Is KQ by R square, and potential on the surface is KQ by R. That is already known. But what happens inside the sphere? Inside the conducting sphere, inside the hollow sphere, we all know that the electric field inside is zero. Yes or no? Do we remember this?
Yes, sir.
But what you have to understand now is potential is not zero, but the potential is constant, and it is same as potential on the surface. That means this value. So potential at any point inside a conducting sphere or a shell is not zero. Electric field is zero, potential is constant. Do you remember I had given you a statement that electric field is zero does not imply that the potential is zero. It implies that the potential is constant. Do we remember this?
Yes, sir.
This one. Electric field is zero, that means the potential is constant inside the conducting sphere or a spherical shell. Electric field, as you can see, is zero, but the electric potential is not zero. In fact, electric potential is constant. Will you remember this? Please note it down. Keep it safe.
Done, sir.
Boys, sir, done, sir. Where are the boys?
Yes, sir.
Okay. This was electric potential and electric field due to what? Your non-conducting sphere or shell. Here is a graph, and as I told you, the graph is very important. Remember the graph between electric field and electric potential, and this is a very nice graph drawn with the spheres so that you understand from where to where electric field is varying and how it is varying. As you can see, electric field inside the sphere in this region electric field is 0. Do you see this? Because this is the region of inside the sphere. In this blue region where the distance is less than r, electric field is 0, and then the electric field becomes maximum at this point on the surface, that is equal to kq by r square, and after that it decreases inversely proportional to r. Electric potential though remains constant kq by r inside up till the surface, and then it decreases. Very good diagram to help you understand electric field and electric potential. I'll give you 2 minutes to note it down. Do we understand the diagram, bacha?
Yes, sir.
Good. Any problem, any doubt, better clear it, because after this class we will not get time for any type of revision of this topic. That is why we are only doing it once, and we may not be able to do it again. So please be very careful about each and every point that we are discussing here. Once you are done, please let me know so that I can move forward.
Done, sir.
Boys, sirs, boys,
Completed, sir.
good, sir. Then comes the formula of non-conducting sphere. At outside point, you know that this is same as the electric field due to a conducting sphere, or electric field due to a point charge, or electric potential due to a point charge. So nothing changes over there when we are talking about outside points or on the points on the surface. But what changes here dramatically is the electric field and electric potential for inside points. If you can remember those, this may not come in your NEET exam inside sphere, but if you remember them, it's an added advantage. So what you have to remember here is outside point, both the things. At the surface of the sphere, you will remember because it is same. Inside points, if you can remember, you just remember this thing, that it is electric field is directly proportional to the radius r. If you can to the distance r, if you can remember just one thing, rest of the thing, if you even don't remember, it may not be of much importance because you may not get this question. But if you can remember it, nothing like it. I give you 2 minutes to write it. Let me know, bacha, when you are done. Girls,
Done, sir.
so shall we move ahead? Okay. As I told you, I keep on telling you which points to remember and which points you may neglect. In this particular thing, as I told you, it may not be important for you to remember the general formula of potential, but if you can remember this one, what is the potential at the center? Potential at the center is 3/2 times the potential on the surface. And potential at the center is greater than potential at the surface, and it is greater than the potential outside. That could be a very good thing. So please write this and remember this. And the last thing that you have to remember about this is the graph between E and R. Remember, inside the sphere, this graph is going like a straight line, and outside the sphere, it is same as the previous graph. Potential, you will not be asked the graph of this potential, but this is how the graph of potential looks like. They can only ask you in case of a very, very difficult NEET if they make. I'll give you 2 minutes to note it down. Have you noted it down, bacha?
Done, sir.
Boys, sir. Shall we move ahead in life, sir? I'm waiting for the voice, sir. Are we done, bacha?
Yes, sir.
Then comes a very important topic. I'm expecting that you might get a question on this topic, potential due to concentric shells. So what they do in this particular type of question, that they give you one shell, and then on the top of that they will give you one more shell, and then they will give you one more shell, and they would ask you what is the potential of this shell and what is the potential of that shell. So you can remember one or two important cases here. One or two important cases here, and how these answers are obtained, I will also explain them. Basically, they ask you to find the potential of the inner shell and the potential of the outer shell. To find out the potential of the inner shell, what do you do it? See, this V1, what you see is the potential of the inner shell, and this V2 that you see is the potential of the outer shell. Now, how do I find the potential of the inner shell and the potential of the outer shell? To find the potential of inner shell, I find out the potential created by the inside sphere, and I again find out the potential created by the outside sphere. I use the formula. For one, I will use formula on the surface. For the other one, I will use formula for inside the shell. Similarly, to find out the potential on the other shell, the outer shell, for the inner shell, I will use the formula for outer shell, and for the outer shell, I will use the formula for potential on the surface of the shell. And this is the way I can find out the potential of these shells. Do we understand this? So you just remember this formula. If you have two concentric shells, what is the potential of inner shell? KQ by R1 plus KQ by KQ2 by R2. What is the potential of the outer shell? KQ1 by R2 plus KQ2 by R2. Have you noted it down, beta? Yes or no? I'll give you 2 minutes. I hope everyone see. I have not seen a question of shells in your NEET up till now, but there could be one or two questions I've seen in very old papers. So that is why I am covering this topic. Once you are done, please let me know so I can give you a question. Anyone, please let me know once you are done, beta, so that I can move ahead in life.
Done, sir.
Boys, sir. Boys are looking quite active today.
Sir.
Done, sir? Oh, no, sir. Shall we move
Completed, sir.
Well done, sir. Then comes this question, sir. This is the question that is most likely to come in your NEET. A hollow metallic sphere of radius 5 centimeters is charged such that the potential on its surface is 10 volt. What is the potential at the center of the sphere? What is the potential of the center of the sphere? Yes, my dear friends, boys and girls. Anyone with an answer? Simple question, bacha. Yes, bacha. No one with an answer, sir? Yes, beta. Are you listening to what we are doing, beta? A hollow metal sphere of radius 5 centimeter is charged such that the potential on its surface is 10 volts. What is the potential at the center of the sphere? What is the answer, beta? Seems like no one is paying attention to what we are writing, beta. That is so heartbreaking. Anyways,
0, sir.
we have written this point inside the sphere. Inside the conducting sphere, electric field is 0 and potential remains same, and it is equal to the potential on the surface. We had written this. We had also drawn this diagram, beta. What are you doing? I think you are more busy in your own chit chat rather than listening to what we are doing. The potential at any point inside the sphere is same as potential on the center of the sphere is same as the potential on the surface of the sphere, and it is k q by r. I am really very disappointed. Potential is same. You could not give this simple answer. So whatever is the surface, whatever is the potential on the surface, same is the potential at the center, and the answer is 10 volts. The answer is 10 volts. Very sad. Anyways, let me put this question. The next one, potential at a distance x. The question is coming. You can add the word is proportional to. So potential at a point x, distance from the center inside a conducting sphere of radius r, charged with a charge q, will be proportional to which one? Out of these 4 options, which is the correct option? Can I have the answer for this one? What will be the potential of a point inside the shell at a distance x from the center of the shell or sphere? Yes, bacha. Anyone with an answer?
Sir,
Yes, beta. Do we have an answer, bacha? No one has an answer. Okay, so it will be same as potential on the surface of the sphere. Potential on the surface of the sphere is kq by r. So you can see that it will be proportional to q by r, and that is your answer, beta. Q by r, option number 1. I thought that you have written it, you would have understood this, but it feels like you are just simply writing and not understanding anything. I'm very disheartened.
sir,
Yes, beta.
sir, am I audible, sir?
Yes, you are audible, beta. Chalo, this is the last question that I have for you based on this, and I hope you can give me an answer for this one. If you can do this one, that means you have understood the entire concept, and I hope this is a question from engineering exam. But if you can do this, that means you understand it, and any question that comes in your medical exam, you would be able to clear it. A hollow conducting sphere is placed in an electric field produced by a point charge. No, that just no, we can't do this one right now. I thought that the question was different. We can't do this. We have not done the concept for this. I thought that you had to find out the electric field due to the shell. That is not the question. So I'll neglect this question and I'll put this question in place of the other one. Can you tell me the answer for this one? The value of potential at a point due to a point charge is? Simple question. A, B, C, D, inversely proportional to the square of the distance, directly proportional to the square of the distance, inversely proportional to the distance, directly proportional to the distance. Can I have the answer for this one? Can I have the answer for this one? Potential due to a point charge. Potential due to a point charge is K Q by X, where X is the distance. So which option is correct?
Option A, sir.
Option C, sir. It is inversely proportional to the distance. We are talking about potential. I'll see you in the next class. I hope you will be able to revise the formulae by the next class. It seems like you have not even seen the formula of potential. That is a very bad thing. Anyways, you have time to go and revise the formula. In the next class, I will be seeing it. I will be moving ahead with the next topic. Yes, still in electric potential. We will see the relation between electric potential and electric field. Bye bye. Take care.